Video Music Retrieval. An Inter-Intra Modal Loss for Cross-Modal Retrieval, by Zeyu, Chen et al., introduces a groundbreaking approach to cross-modal retrieval, focusing on the relationship between videos and music. The authors propose an inter-intra modal loss function that leverages both intermodal and intramodal similarities to enhance the retrieval performance. This method is based on the idea that videos and music share common underlying concepts, such as mood, tempo, or genre, which can be used to establish connections between them. To capture these relationships, the authors introduce two types of losses: intermodal loss and intramodal loss. Intermodal loss measures the similarity between video and music pairs, encouraging the model to learn a shared representation space where videos and music can be compared directly. This is achieved through a contrastive learning framework, where positive pairs, i.e., videos and their corresponding music, are pulled together, while negative pairs are pushed apart. Intramodal loss, on the other hand, aims to preserve the structure within each modality. For videos, this involves maintaining the temporal relationships among frames, while for music, it involves preserving the melodic and rhythmic patterns. This is achieved by applying self-supervised learning techniques, such as predicting future frames in videos or next notes in music sequences. The authors also propose a multitask learning framework that combines both intermodal and intramodal losses. This allows the model to learn from multiple sources of supervision simultaneously, leading to more robust and generalizable representations. Experimental results on several benchmark datasets demonstrate the effectiveness of the proposed approach, outperforming state-of-the-art methods in video music retrieval tasks. The authors also provide insights into the learned representations, showing that the model can capture meaningful relationships between videos and music at various levels of abstraction. Overall, this paper contributes to the field of cross-modal retrieval by introducing a novel loss function that leverages both intermodal and intramodal similarities. The proposed approach has potential applications in various domains, including multimedia search engines, video editing software, and music recommendation systems. The paper presents an inter-intra contrastive learning model for video music retrieval tasks, focusing on selecting background music for videos. This model, IICLVM, uses a global sparse sampling method to extract features from both video and music. These features are then encoded using video and music encoders, respectively. The intermodal similarity matrix and intramodal similarity matrices for video and music are calculated, with the intermodal loss derived from the intermodal similarity matrix and intramodal losses calculated from the intramodal similarity matrices. Previous works in cross-modal retrieval tasks include CLIP, which uses a large number of image-text pairs for pre-training, and its extensions to video text and audio text retrieval tasks. Other works have explored different pre-training methods, such as BLIP, and optimized cross-modal retrieval tasks by redesigning loss functions. Factors like emotion, location, style, genre, comments, lyrics text, and user personality have been considered in BGM selection for videos. Pre-trained visual and audio feature extractors play a crucial role in video music retrieval tasks, with frame-level features like ResNet 50, Inception v3, VIT, and ClipVision, as well as video-level features such as i3D, Slow Fast, and Video Swin Transformer being used to extract video embeddings. The paper highlights the importance of these feature extractors in restricting retrieval performance and the need for further improvements in this area. The IICLVM framework, or Inter-Intra Contrastive Learning for Video Music Retrieval, is a novel approach designed to enhance video music retrieval by leveraging inter-intra modal loss. This method utilizes global sparse (GS) sampling to extract features from the entire video and music sequences, eliminating duration information and enabling content-based retrieval. Sequence encoders, such as BILSTM or Transformer encoder, are applied to the frame-level video and music feature sequences to extract temporal information. The encoded video and music features are then fed into the inter-intra modal loss function. The inter-intra modal loss consists of two components: intermodal loss and intramodal features distance distribution loss. The intermodal loss is calculated based on the cosine similarity matrix, aiming to increase values on the diagonal and decrease those in other positions. This encourages the model to learn a shared representation space for video and music. The intramodal loss preserves the relative feature distribution of music samples in the encoder output, preventing false negative sample pairs from moving away from each other. This ensures that the retrieved music remains relevant to the video content even when considering background music. In summary, IICLVM introduces a novel approach to video music retrieval by utilizing inter-intra modal loss, which improves the accuracy and relevance of retrieved music by learning a shared representation space for video and music while preserving the distribution of music features. In the video modality section of the research paper, the authors delve into the calculation of intramodal loss. They introduce two similarity matrices, SV and SV, which describe the similarity of different video features before and after the encoding process. The intramodal loss is calculated as the difference between SV and SV, aiming to achieve invariance in feature distribution before and after encoding. The music modality is processed similarly, and the total intramodal loss is a weighted sum of the intramodal losses for both modalities. The inter-intra modal loss is then computed as a weighted sum of the intermodal loss and the total intramodal loss. This framework can work with various feature extractors and sampling methods. The paper introduces a groundbreaking approach to video music retrieval, leveraging the IICLVM framework with a focus on the inter-intra modal loss function. This method significantly improves the retrieval performance compared to previous works, achieving state-of-the-art results in both video-to-music and music-to-video retrieval tasks. The authors evaluate different sampling methods, including fixed duration, FD, and global sparse, GS, sampling, and find that GS sampling significantly enhances the retrieval performance. They also compare various types of encoders, such as fully connected layers, graph convolutional networks, self-attention, and BILSTM, and demonstrate that sequence models like self-attention and BILSTM perform better due to their ability to consider temporal information. The impact of the inter-intra modal loss, TO loss, is also assessed, showing an improvement of 0.5% to 3% compared to CLVM across various sampling methods. The proposed framework IICLVM consistently outperforms previous works in both retrieval tasks. A subjective evaluation is conducted to assess the quality of the retrieved music for videos. The results indicate that the top 1 music retrieved by the model BILSTM, IICLVM, is preferred over randomly selected music, demonstrating the effectiveness of the proposed approach in selecting suitable music for videos. The paper introduces a novel framework for video music retrieval, IICLVM, which incorporates an innovative loss function called TO loss. This loss function is designed to enhance the model's generalization capabilities by maintaining pre-trained feature distribution within the two modalities during training on noisy cross-modal datasets. The IICLVM framework has shown promising results in video music retrieval tasks, achieving state-of-the-art results on the YouTube 8M dataset. The TO loss is found to be valuable for other cross-modal retrieval tasks as well, such as image text, audio text, and video text retrieval. It also performs well with a small number of training samples. The authors acknowledge potential for further enhancement but highlight the encouraging findings of this research. The paper also discusses the impact of batch size on retrieval performance, showing that increasing batch size tends to decrease due to increased noise. However, the intra-loss in IICLVM can reduce the influence of this noise and significantly slow down the reduction of. Additionally, the paper presents experiments on the Caltech 256 dataset, demonstrating the effectiveness of TO loss in enhancing retrieval performance under different levels of noise. As the noise increases, the TO loss group shows more and more improvement compared to the non-II loss group. Overall, the IICLVM framework with the TO loss has demonstrated strong performance in video music retrieval tasks and has potential applications in various cross-modal retrieval tasks. In cross-modal retrieval tasks, the correlation between different modalities, such as images and music, is crucial for optimal performance. To address this, a novel loss function, TO loss, has been developed to enhance the correlation between modalities. The TO loss function is designed to mitigate the negative impact of noise in the batch during training, which can significantly degrade retrieval performance. By incorporating TO loss into the training process, the model learns to be more robust against noise, improving the correlation between input and output modalities. Experiments on the Caltech 256 dataset demonstrate the effectiveness of two-loss in improving retrieval performance. A stacked bar chart illustrates the relationship between the increment of with or without two-loss and the noise level in the batch. As the noise level increases, the without two-loss drops rapidly, whereas the effect of two-loss on improving is significant, particularly at high noise levels. The two-loss function has the potential to become a versatile tool in cross-modal retrieval, particularly in areas such as retrieval performance on large datasets and the development of noise-resistant methods for end-to-end retrieval models. By addressing the challenges of noise in the batch, two-loss can further enhance the performance of cross-modal retrieval systems. The paper provides a comprehensive overview of the two-loss function and its application to cross-modal retrieval tasks, highlighting the importance of addressing noise in the batch during training. Future research directions include the development of more robust and efficient cross-modal retrieval models, further exploring the potential of two-loss in improving retrieval performance. The page discusses various research papers in the field of computer vision and audio processing, highlighting key contributions and methodologies. It includes a comprehensive overview of recent advancements in object detection, image segmentation, and audio signal processing. The section on object detection delves into the latest techniques, such as YOLO and SSD, emphasizing their strengths and limitations. In image segmentation, the focus is on methods like FCN and UNet, detailing their applications and performance metrics. The audio processing segment covers topics like speech recognition, music classification, and audio feature extraction, highlighting the importance of deep learning architectures in these areas.